Hello again, and here you are at the introduction to the network, and today we will be focused at the physical layer. The physical layer of the OSI model sits at the bottom of the stack, and if we refer to the TCP/IP model, the physical layer is part of the network access layer. Without the physical layer, we will not have a network. And at this module, we will explain in detail the three ways to connect to the physical layer. And what we will learn in this module, we will learn about the purpose of the physical layer, where we will describe the purpose and the function of the physical layer in the network. We will learn about the physical layer characteristics, where we will describe the characteristics of the physical layer, and we will learn about copper cabling, where we will identify the basic characteristics of the copper cabling. We also will be focused even at the UTP cabling, where we will explain how the UTP cable is used in Ethernet networks. Also, we will be focused even at the fiber optic cabling, where we will describe the fiber optic cabling and its main advantages over the media. And lastly, we will be focused even at the wireless media, and we will explain how the connect devices using wired and wireless media. So let's go on. The model of the physical layer will be divided in three parts. In three sections. At the first part, in the first section, we will be focused at the purpose of physical layer and physical layer characteristics. So let's go and see those two topics. The same is if you are trying to connect a local printer in the home or a website in other country. Before any network communication can occur, a physical connection to a local network must be established. A physical connection can be a wired connection using a cable or a wireless connection using radio waves. The type of physical connection used depends upon the setup of the network. So, for example, in many corporate offices or in many business, employees have desktop or laptop computers that are physically connected via a cable to a shared switch. This type of setup is wired network, and the data is transmitted through a physical cable. Despite this, many businesses also offer wireless connection for laptops, tablets, and smartphones. With wireless devices, data is transmitted using radio waves. Wireless connectivity is common as individual and business alike discover its advantages. Devices on a wireless network must be connected to a wireless access point or a wireless router, as it is shown in this figure. So, the three components of the access point in this case is the wireless antenna, and at this access point, the wireless antenna is integrated inside the router. And they will have also the several Ethernet switchboards, and these Ethernet switchboards may be used to connect the devices physically at the local network. And we will have even the internet port, where with this we will be able to connect our local area network with the internet. Most homes offer both wired and wireless connectivity to the network. And in this figure, we will be able to see the wired connection of a laptop with an access point. And as you can see, the laptop is connected with one of the Ethernet switch ports. For the devices to connect to the network, they must have a network interface card. The network interface card can be for the two types. We may have an Ethernet network interface card, where in this case is used for wired connection, as it is shown in the figure in this case. But despite this, we will have even the wireless local area network or a wireless LAN network interface card, and is used for wireless connectivity. An end user device may have one or both types of network interface card. A network printer, for example, may have only the Ethernet network interface card, and therefore must connect to the network using an Ethernet cable. But other devices, such as tablets or smartphones, might only contain a wireless network interface card and must be able to use only wireless connection. And we must know that all physical connections are equal in terms of performance level when connecting to the network. The physical layer provides the means to transport the bits that make up a data link layer frame across the network media. This layer accepts a complete frame from the data link layer and encodes it as a series of signals that are transmitted to the local media. The encoded bits that comprise a frame are received by either an end device or an intermediate device. And as it is shown in the encapsulation process, the last part of this process shows the bits being sent over the physical medium. The physical layer encodes the frames and creates the electrical, optical, or radio waves signals that represent the bits in each frame. These signals are sent over the media one at a time. The destination node physical layer retrieves these individual signals from the media, restores them to their bit representation, and passes the bits up to the data link layer as a complete frame. The physical layer standards address three functional areas: is the encoding areas, signaling, and physical component, where the physical components are the electronic hardware devices, media, and other connectors that transmit the signals that represent the bits. Hardware components such as network interface cards, interface and connectors, cable materials, and cable designs are all specified in standard association with the physical layer. The various ports and interfaces on the, for example, Cisco 1941 router are also examples of physical components with specific connectors and pinouts resulting from standards. Encoding or line encoding is a method of converting a stream of data bits into a predefined code. Codes are grouping of bits used to provide a predictable pattern that can be recognized by both the sender and the receiver. In other words, encoding is the method of pattern used to represent digital information. This is similar to how Morse code encodes a message using a series of dots and dashes. For example, Manchester encoding represents a 0 bit by a high to low voltage transition, and 1 bit is represented as low to high voltage transition. An example of that it is shown in this figure. The transition occurs at the middle of each bit period. This type encoding is used in 10 megabits Ethernet. Faster data rates require more complex encoding. The physical layer must generate the electrical, optical, or wireless signals that represent the 1 and 0 on the media. The way that bits are represented is called the signaling method. The physical layer standards must define what type of signal represent as 1 and what type of signal is represented as 0. This can be as simple as a change in the level of an electrical signal or optical pulse. For example, at the electrical pulse, a long pulse might represent as 1 and the short pulse might represent as 0. This is similar to the signaling method used in Morse code, which may use a series of on-off tones, lights, or clicks to send a text over telephone wire or between ships at sea. And this is the illustration of the electrical signals over the copper cable, the light pulses over the fiber optic cable, and the microwave signals over the wireless media. Different physical media support the transfer of bits at different rates. Data transfer is usually discussed in terms of bandwidth. Bandwidth is the capacity at which a medium can carry data. Digital bandwidth measures the amount of data that can flow from one place to another in a given amount of time. Bandwidth is typically measured in kilobits per second, megabits per second, or gigabits per second. Bandwidth is sometimes thought of the speed that bits travel. However, this is not accurate because, for example, in both 10 megabits and 100 megabits Ethernet, the bits are sent at the speed of the electricity, but the difference is the number of bits that are transmitted per second. A combination of factors determines the practical bandwidth of the network, and there are the properties of the physical media and the technologies chosen for signaling and detecting network signals. Physical media properties, current technologies, and the law of physics all play a role in determining the available bandwidth. And at this table, that is shown the common use unit of measure per bandwidth. We have the bits per second, kilobits per second, megabits per second, gigabits per second, and terabits per second. And there is explained even the equivalence in bits per second for each of the unit. There are three terms used to measure the quality of bandwidth, and the first one is the latency. Latency refers to the amount of time, including delays, for data to travel from one given point to another. In an internetwork or a network with multiple segments, throughput cannot be faster than the slowest link in the path from source to the destination. Even if all or most of the segments have high bandwidth, it will only take one segment in the path with low throughput to create a bottleneck in the throughput over the entire network. And the second measured is the throughput, where it measures the transfer of bits across the media or given period of time. Due to the number of factors, throughput usually does not match the specified bandwidth in physical layer implementation. Throughput is usually lower than the bandwidth. There are many factors that influence the throughput. Is the amount of traffic, the type of traffic, or the latency created by the number of network devices encountered between source and the destination. And there are many online speed tests that can reveal the throughput of an internet connection, and you can test even the internet connection at your home. The last measure for the quality of the bandwidth is the Goodput. The Goodput is the measure of usable data transferred over a given period of time. Goodpoint is throughput minus traffic overhead for establishing session, acknowledgement, encapsulation, and retransmitted bits. Goodput is always lower than throughput, which is generally lower than the bandwidth. And by this, we end the two topics that we had for the day. The was of the physical layer and the characteristic of the physical layer. And this was the end of our first session for the physical layer. Hopefully you enjoy it, and we will see together at the next Monday. And please do not forget to subscribe at my YouTube channel AA Networking and hit the notification button for you to notify when the new video comes out. See you soon.